so today we are going to review solving rational inequalities again, and we will be able to graph their solutions on a number line. So in class we talked about the steps to solving rational inequalities. So once again, our steps for solving rational inequalities are to 1, find our key points. And to find our key points, we need to first switch our inequality to an equal sign and solve the equation, just like we were doing before when we were solving rational equations. Once we get our solutions to the equation, we are going to plot them on a number line. But what determines whether or not those points are open or closed is the original inequality. So if it is greater than or less than, we'll have an open circle. If it's greater than or equal to or less than or equal to, we'll have a closed circle at that point. Then the second part of key terms, finding our key points, is to set our denominators equal to 0 and solve. We want to find the values that make our denominator 0 because we know that those extraneous solutions cannot be part of our solution set. So those are also key points. We're going to find those key points and also plot them on the number line. But here they will always be open because we do not want them to be a part of our solution set. Then once we go to the number line, we're going to separate our number line into regions. Those regions are determined by the points that we just found. Then we need to pick a test point in each region. Notice this can't be one of the points on the border of the region, and we want to plug in those test points into our original inequality. If that's true, then that region will be part of our solution set. If it is false, then it will not be part of our solution set. So make sure we have this all copied down, and we'll get to our example. This is also number 4. From the worksheet we had in class today. So, first thing I'm going to do is rewrite my inequality as an equation. So 1 over n is equal to n plus 1 over 4n squared plus n plus 3 over 4n squared. So now I'm going to solve this just like I was solving rational equations. I first need to find my LCD because I'm going to multiply my LCD to the numerator of each term to cancel out my denominator. So I'm going to copy my first factor, n. Then I'm going to check my second. I do not have a 4 in my LCD, so I am putting a 4 in my LCD. I only have one n, and in my second term I have n squared, so I need to put another n. Then I'm good with my second term. I'm going to check my third term, and I have a 4 in my LCD, and I have an n squared. So my LCD is 4n squared. I'm going to multiply each numerator by 4n squared. And I am going to cancel out. So if I have an n in my denominator, I can cancel out one of these n's, and I'm going to be left with for n is equal to. I have a 4n squared and a 4n squared, so I'm left with n plus 1. I have another 4n squared and another 4n squared, so I'm left with plus n plus 3. I now need to solve for n, so I'm going to combine my terms. And n is equal to 2. I'm going to look at my original inequality to see that it is just less than. So now when I go to plot my point on the number line, I know that I'm making an open point at 2. Then I'm going to go back and find my extraneous solutions. So I'm going to write this in purple. And I have to set my denominator equal to 0. So if I set n equal to 0, my first extraneous solution would be n is equal to 0. Then just to double check, I don't have any other extraneous solutions. I'm going to check 4n squared is equal to 0. Divide by 4, n squared is equal to 0. N is equal to 0 also. So my extraneous solution is n is equal to 0. Since these are extraneous, I know that I have to have an open circle on my number line. So at 0, I'm going to put an open circle on my number line. Now that I have my key points, I need to separate my graph into regions. So, going to use this dotted line and make a line through the points that I already have. I need to pick a test point from this red section, the green section, and the blue section. If the test point solution is true, then that region will be part of our solution set. So for red, I'm going to choose -1. I'm going to plug it into my original inequality. So I have 1 over -1 is less than -1 plus 1 over 4 times -1 squared plus -1 plus 3 over 4 times -1 squared. I then get -1 is less than 0 because -1 plus 1 is 0. Any 0 divided by anything will be 0. Plus 2 divided by 4 is -1 less than 1/2. Yes, so this solution set works. We then have to plug in a value from the green section. I'm going to pick 1. So now I have 1 divided by 1 is less than 1 plus 1 over 4 times 1 squared plus 1 plus 3 over 4 times 1 squared. So I have 1 is less than 2 over 4 plus 4 over 4 is 1 less than 6 over 4. Yes. So my second solution set works. Now my last region is the blue region. I'm going to pick 3 to test. So I have 1 over 3 is less than 3 plus 1 over 4 times 3 squared plus 3 plus 3 over 4 times 3 squared. Going to simplify. 1 over 3 is less than. 4 over 3 squared is 9. 9 times 4 is 36. Plus 3 plus 3 is 6. Once again, 4 times 3 squared is 36. Is 1/3 less than 10 over 36? No, because 1/3 is the same as 12 over 36, which is greater than 10 over 36. So our blue section does not work. Our final answer, or the solution to the problem, would then be, we are less than 0, and we are in between 0 and 2. So to write out those inequalities, I want x to be less than 0, or I want x to be in between 0 and 2. That is your solution and answer to the problem.